reactions, something now you should do is counting number of the carbons in the product, number of the carbons in the starting material. This one and that one. What's the difference is? That benzene ring is still there, that carbon chain is still there, that's still there, but this was added, right? You just have to remember, you just have to see that this carbon is that carbons. So we're not just replacing chlorine with an OH, we are adding the CH2. So that should give you the clue what to use, right? Because we're adding a CH2OH. So what we do, we make a magnesium, we add a magnesium to make a greener. But in order to do this, you have to get formula volumes of that, but that's a formaldehyde. If you're using a formaldehyde, you're adding a one carbon and it becomes an OH in the end. So that is something that you need to remember. But what we can ask is, after testing, after telling you what to do with this one, we ask this as a question. Then how would you do it? It looks pretty same as that. That's why I keep asking you. You got to count. Which carbon is that carbon? Is this one. So you are adding 2 carbon and OH. So it cannot be done by this because that will add just 1 carbon. So you got to search your databases. Do I know any reaction that has a 2 carbon and it becomes an primary alcohol? Then you got to remember that 2 carbon with an oxide that should come from the aldehyde. I mean, I'm not saying epoxide. So the Grignard make an attack to the epoxide. That is a 2 carbon here, and this oxygen get protonated in the end. Then it'll be this. I can keep going on. What about this one? How do you do it? It's all same reaction, all similar looking, but it's going to require a different way to do it. How are you going to do it? How many carbons added? 0. We didn't add a carbon. So this is not the reaction with the Grignard. This is not the reaction with the epoxide. This is simply just replacing chlorine with an OH. Do you know any reaction to bring that? No. I said too, if you get the hydroxide, that is a nucleophile. Of course, it's base too, but it makes an attack and then you can kick out and make this alcohol by itself too. I can keep going on. How are you going to make that? Anyway, that's, you get the clue. I'm pretty sure that we can make the question very challenging by just adding one more carbon or cutting it out, changing the reagents. It's all made confusing because you have to have a good briefs of all the reactions that you know. And then you should know the detail. That's what I'm telling you. I like this question. So that's why I really want to do it if we have time. Okay, I will quit. This one, chlorine is here, but OH there. It's almost like the same question that you have seen, right? It's almost the same question. What it is 2 carbon was there, just 1 carbon. I got the carbon cut away. So how would you cut the carbons away? I mean, adding the previous slides, add the carbon. 1 carbon added, 2 carbons added, sometimes 0 carbons added. But now I just cut it away. How would you do it? You have to break a bond. Carbon bond has to be broken. But single bond, breaking the carbon from a single bond is very difficult. But you should remember that breaking double bond is a lot easier. So if you have a double bond, you can break it. Single bond breaking is difficult. So then, can you make this one from that? Sure, you just have to treat it like a T-butoxide. I treat the T-butoxide because you need an E2 elimination reaction, not a substitution reaction. It's a primary alkyl halide. So if you're using alkoxide, it will make it SN2 more than E2. So that's why T-butoxide, Berkey base, right? That ensure the E2 elimination reaction major pathways. That makes this. Now in the double bonds, we can cleave it. What would you use to cleave that? You can do permanganate. If you do that, you get the carboxylic acid. And do I know any reaction to convert the carboxylic acid to primary alcohol? It has to be liquid hydrate, not the sodium borohydride, right? Because it's carboxylic acid. But that's not another way. If you do the ozonolysis, you can create that as the aldehyde. Aldehyde, you can use a sodium hydride or lithium hydride, depending on what you use.